Clouds are one of the most important components of the atmospheric system. They serve as short-term repositories for water, but they also reflect and absorb energy and thereby redirect large amounts of energy either towards or away from terrestrial ecosystems. A key thing to think about for water is that it both reflects and it warms. It absorbs energy but also reflects energy, depending where it is in the atmosphere and in what form it is. And therefore, water has the potential to cool or to heat when it's in the atmosphere. And in part, we really need to think about not only clouds and their form, but where they are in the atmosphere and differences between high clouds and low clouds. This diagram shows some of the major cloud types that there are. And among these types, they're really categorized based on their position in the atmosphere. So these high clouds are often the cirrus clouds, for example, intermediate clouds like altostratus clouds, and then relatively low clouds like cumulus clouds. And you can see that each of these are in different strata of the atmosphere. And cirrus clouds have a much different effect on the climate below them than, say, a cumulus cloud would. Now, one important thing to think about for clouds is not only the type of cloud, but really how they form in the water droplet size. So we talked about aerosols and how they can serve as condensation nuclei. In atmospheres without a lot of aerosols, clouds are generally composed of relatively large water droplets, and these clouds end up looking relatively dark, and they let a relatively large amount of light through and don't reflect that much. But when you have a lot of aerosols in the atmosphere, the clouds are made up of much smaller water droplets. The clouds themselves end up being more dense, they appear brighter, and they reflect away a lot more light. So one of the impacts that humans have and other components of ecosystems like volcanoes on the atmosphere is what that aerosol loading is. And if we have a lot of aerosols in the atmosphere, they are going to generate clouds that reflect away a lot more light and let less light through. This influence of aerosols and clouds is called the indirect effect, and it's a large source of uncertainty in our projections of climate change. Now, another important thing to think about when we think about the atmospheric system is that humans make clouds. Yes, we influence how much aerosol there is in the atmosphere, which generates clouds of different types. But also, we have other activities too. And this here is an image from the Pacific Ocean. In each of these long linear clouds is a ship track, and this is a major shipping lane between Asia and North America. And you can see that every time a ship had passed through, that it left what was equivalent of a contrail. But these are from ships, and they form a large number of clouds. Airplanes form contrails too, and this is an image that was taken over the southeastern United States. And you can see each of these lines is a different contrail. Now, the effect of these contrails really was relatively unappreciated. And there's always contrails in the atmosphere. And understanding the effect of these contrails had always been relatively difficult. I remember after 9/11 when they shut down all the air traffic for somewhere on the order of 2 days, that was one of the few times that scientists could study the atmosphere in the absence of contrails, because always there's contrails that are present. And for 2 days we essentially shut down air traffic and the production of these contrails. And they found that really there were differences in climate because of that, differences in weather, that these contrails really are pretty good at absorbing heat, and they reflect heat back downwards. They warm the earth, especially at night. And so the temperatures that we saw at night were a lot cooler once these clouds were not formed. A lot more energy could escape up to space again. So the net effect of clouds is sometimes relatively difficult to determine. If you ask whether clouds will warm or cool the atmosphere, whether it's going to warm or cool ecosystems, the answer is it depends. And it's going to depend on where those clouds are formed and how those clouds form also. That aerosol loading determines how dense those clouds are, and based on the water droplet size and how much light they're going to reflect away versus let through. So clouds are an important component of the climate system, of the atmospheric system, and to some degrees they're relatively unknown as far as what their net effect is going to be in the future.